Welcome, everyone. Today, we are tackling a critical but often overlooked challenge in AI engineering, handling capability shifts. When Anthropic releases a new model, like moving from Claude 4.6 to Opus 4.7, or updates its underlying behavior, workflows that ran perfectly yesterday might behave unpredictably today. We are going to build the mindset and frameworks necessary to adapt your systems seamlessly. Let's get started. Let's begin by defining an AI capability shift. What is it? It's the moment a model's intelligence, API structure, or default behavior evolves. The basics are that as models like Claude get updated, they interpret your existing instructions differently. Why does this matter to you? Because if you treat an AI model like static, traditional software, your systems will break. For example, a prompt that previously required heavy coercion to get a complete answer might cause a newer, highly proactive model to hallucinate or overgenerate. How do we survive this? We abandon the set it and forget it mentality. Our deep dive reveals that your prompt is simply a steering wheel for a dynamic reasoning engine. When Anthropic drops a new engine into the car, your steering inputs your prompts must be recalibrated. Take a look at this flowchart mapping out the reality of version updates. When a model version update hits, it causes a behavioral shift. If the model becomes more literal, your old prompts might overtrigger. If it gains new capabilities, your old, hacky workarounds become completely obsolete. Both of these paths must route into a continuous evaluation loop. Only by constantly evaluating the new baseline can you reach the final green node, stable production. To manage change, we must first categorize it. What are the types of AI evolution? They fall into three buckets: feature additions, feature deprecations, and behavioral shifts. The basics are simple. Additions are cool new toys, like the computer use tool. Deprecations are things being taken away. Behavioral shifts change the model's actual personality or reasoning. Why categorize? Because your reaction must match the threat. A deprecation will instantly break your code, while a behavioral shift just makes your outputs look weird. How do you handle this? You critically analyze release notes. For our deep dive, let's look at behavioral shifts. They are notoriously tricky. For instance, when moving to Opus 4.7, the model became vastly more literal and opinionated. It stopped silently guessing what you wanted. If you aren't explicitly precise about your scope, the new model won't do it. You have to adapt. This mind map categorizes the chaos of an AI update. From the center, AI evolution branches into three paths. Feature additions give us powerful new tools like adaptive thinking. Feature deprecations force us to update our code, like the removal of pre-filled responses on the latest models. Finally, behavioral shifts affect the soft skills: more literal instruction following, changes in how verbose the model is, and shifts in its writing style. You must monitor all three branches. How do professionals handle a new Claude release? They use the Technical Change Management Framework. What is this? It's a phased, systematic timeline for adopting new models safely. The basics dictate that we assess for the first 3 days, integrate in a controlled manner during week 1, and optimize during weeks 2 through 4. Why so cautious? Because swapping a model ID in production on launch day is amateur behavior. Giving in to FOMO leads directly to broken applications. How do you execute this? You start by reading the migration guide to patch any breaking API changes, then you run tests in staging. Our deep dive recommendation is to use Claude's evaluation tool in the console. You can run your prompts side by side, say, Sonnet 4.5 against 4.6, using a golden dataset of test cases. This provides objective, mathematical proof of how the capability shift affects your specific business logic. This state diagram maps your survival timeline when a new model drops. Following the model release, you enter the technical assessment phase for 3 days, focusing purely on fixing breaking API changes. Once stable, you transition to controlled integration in week 1, running strict staging evals using the Claude evaluation tool. Only after the model proves itself do you move to systematic optimization in weeks 2 to 4, culminating safely in production deployment. When a smarter model arrives, your prompts must go on a diet. This is prompt migration and rebaselining. What is it? It is the deliberate removal of old prompt hacks. The basics are counterintuitive. Newer models require less handholding. You must strip away complex scaffolding. Why? Because if you use an old anti-laziness prompt on a highly proactive model, it will overgenerate and hallucinate. How do you rebaseline? You delete the fluff. Send the absolute simplest version of your goal to the new model, and only add constraints back if it makes a mistake. Look at our sample code for upgrading to adaptive thinking. Instead of manually guessing a token budget, You simply set the type to adaptive. In our deep dive, we learn that forcing manual limits on modern models actually cripples their ability to dynamically interleave reasoning with tool use. Trust the upgraded engine. Look at this prompt reduction funnel. We start at the top with your legacy complex prompt, filled with old hacks. The immediate next step is to strip all workarounds. We then test the bare minimum intent against the new model. We hit a decision gate. Did it succeed? If yes, congratulations, you deploy a lean prompt that saves tokens and latency. If no, you add exactly one constraint back and test again. This loop guarantees the most efficient prompt possible. To be a true professional, you must master building resilient, future-proof workflows. What does this mean? It means architecting systems that don't panic when the AI landscape shifts. The absolute basics: never use generic model aliases in production. Always pin your versions. Why is this critical? If you just ask for the latest model, your provider might update it overnight. You wake up, the model's tone has changed, and your entire application crashes. How do we prevent this? Use explicit IDs, like Claude Opus 4-7. Furthermore, mandate structured outputs using JSON schemas. For our deep dive, understand that structured outputs decouple the AI's personality from your code. Even if a new model update makes Claude significantly more talkative, the API guarantees your payload remains strict, valid JSON. Your business logic remains perfectly insulated from the AI's behavioral shifts. This architecture diagram visualizes our defensive layers. On the right, the AI provider constantly pushes anthropic updates and shifts. This chaos hits our protection layer first, specifically our pinned model version. Because it is pinned, surprise updates are blocked. The data then flows through structured outputs, guaranteeing its shape, before hitting the strict JSON parser in our application layer. The chaos of AI evolution is completely neutralized before it touches your business logic. To survive in AI, you must cultivate the timeless skills of AI adaptation. What are these? They're the core human competencies that remain incredibly valuable regardless of which model version was released today. The basics: stop memorizing where buttons are on the interface, and start mastering problem decomposition and clear communication. Why? Because specific UI features like artifacts or projects might get completely overhauled next year, but logical reasoning never goes out of style. How do you do this? Practice the anti-obsolescence strategy. Focus entirely on why a system works, not just how to type the syntax. In our deep dive, consider the mindset of a power user. They never say, "I know how to click the Claude computer use button." They say, "I know how to decompose an autonomous UI workflow." The button click will eventually expire, but the architectural mindset transfers to whatever technology comes next. This mind map highlights your ultimate survival toolkit: timeless AI skills. From the core, we branch into 4 immortal competencies. Problem decomposition allows you to break massive tasks into manageable steps. Clear communication ensures you can set constraints for any future model. Adaptability keeps you eager to test new baselines instead of resisting change. And critical evaluation ensures you never blindly trust an output, spotting hallucinations regardless of how convincing the newest model sounds. Let's apply this to a real-time, high-stakes use case: migrating an enterprise agent. The scenario: you manage a customer support bot running on an older model, and you need to upgrade to Opus 4.7 to unlock the massive power of adaptive thinking. Here is the execution. Step 1. The developer uses the bundled Claude API skill locally, typing /Claude API migrate. The skill automatically scans the codebase, flagging deprecated API calls. Step 2. The developer removes outdated temperature parameters, updates the model ID, and swaps the rigid, manual thinking budget for the new adaptive flag. Step 3. They run their evaluation suite in staging. They notice Opus 4.7 is a bit too direct. Because they anticipated behavioral shifts, they simply adjust the system prompt to explicitly mandate a warm, empathetic tone. The outcome: a flawless, zero downtime upgrade. The bot now natively reasons and fetches customer data with unprecedented accuracy. This sequence diagram maps the perfect enterprise migration. The developer runs the migration tool against the codebase, which immediately flags deprecated parameters. The developer swaps the ID and enables adaptive thinking, then pushes to the staging environment. The staging evals catch the behavioral tone shift. The developer calmly updates the system prompt to restore warmth, and only then pushes the safe, validated code into production. Chaos managed systematically. Let's wrap up with best practices for continuous adaptation. First, implement the weekly check-in. Dedicate just 5 minutes every Friday to scan Anthropic's release notes. Don't drown in hype, just check the facts. Second, use the progressive adoption method. When a feature drops, learn it, test it on a low-stakes task, integrate it into a single workflow, and only expand once it proves valuable. Third, build a community. Share your discoveries about silent behavioral shifts with other developers. You cannot track everything alone. To summarize, AI capability shifts are inevitable, but your anxiety doesn't have to be. True resilience comes from structured evaluation testing, pinning your versions, and relying on timeless critical thinking over fragile prompt hacks. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final diagram illustrates the progressive adoption method. You learn the update and immediately test it in a low-stakes environment. If it works, you integrate it into just one workflow. Then, you evaluate the ROI. If the value is low, you ruthlessly discard it. If the value is high, you expand gradually and share your success with the community. This loop turns constant change into your ultimate competitive advantage.